Okay, let us go back to that. So these three things are like a very famous preprocessor directive: include, define, pragma. This include is to include a library file in another program to your existing program. That means you will make a combined output, right? That combining these two will be taken care by preprocessor, and the generated file will be given to compiler as input. Then define. I also explained that define with the example of finding with the pi. Right now pi, I defined pi as 3.14, and I also told where that pi use will be stored, right? How they replace the pi when we compile the program right now. So that I explained. The pragma is it is just like for which hardware or more details about your compilation sequence. For that they use pragma. We will study that in detail later point of time, right? Then identifier are variables that we use in Cino. What they are? They are named in memory location, right? Or also a function, right? So let us say I declared this one now. Let me declare a function here. I call that function at int add, right? And it accepts int command two integers, right? This is called as function prototype. That means you are defining what your function name is and what are the inputs to that function. Now, at the end of this main, I define that function. That means I describe that function in add int x comma int y, return x plus y. Right now. Okay. Add is a function, right? So I describe that function. Now I am going to call that function and I want to know where this particular add function is stored. Is it possible for me? Can I get the address of add? Add is a function only, no? That function accepts two parameters and then return the result, x plus y, sorry. It add those two variables and return the result. My question is it possible for me to get address in which the add is stored? How they see they if something is function means how they store, where they store that code. See, this code is stored in a program memory. These things are these expressions are stored in a program memory. Perfect, right? And these are stored in RAM. That means data memory, probably in stack. This add also stored somewhere. This function also stored somewhere. Add is stored in data memory or in program memory. Come on.
In program memories,
Why?
because it's the part of the program.
Okay, it is a program. Actually,
Yeah.
it is an instruction. But what about X and Y?
Uh, yeah, it's a data type. It's a data variable, so it is a input to the this functions.
Okay, if that is the case, will they store it in RAM or in program memory? That is my question. Let us check. So I have a function. So I do like I just print what I did here, right? So I want to know where, okay, add is stored in the program memory. where these two variables are stored. They have to store somewhere, no, only then they can process it, right? So let me understand their address. For that, just we can use this inside this function. We can do like that, no? Right? And then we get a result right now, addition result. They have to store that result also somewhere, right? So what I do here, I just say here we have E, no, E equal to add A comma B. So I let me comment these lines. So this is the function that I call. I also want to know where this address is stored in the program memory. For that, what I do the same. Can I do like that? Will that work? Let us do. See, they are printing different addresses. Right. So actually, as there is some sort of, this is address of add function of x, address of y. Right. Actually, here I made a declarations. Right. And then I stored some values in those variable. And then I use those, I pass those variable to a function called add. I get the result, I store that result in E. Right. So these variables used in the functions also some memory locations only. They have to store them somewhere. What is their address? Where they reserve the address for them. Right. We have to know. We want to know. Right. They are not reserving memory in program memory. Actually, they are data. So they have to store it in data memory only. Let us see, based on the addressing that we had in the past, let us see where they are stored. Let us inspect that. So they start from this is like 6422. It appears to us they are storing these things also in the memory location. Which memory location? Stack memory only. See, 6056. Right. For A, B, C, D, they come from 95, 94, and then from there 4 byte 8, from 4, that is from here 4 byte 8, like that they are going right now. From here 88 plus 4, 1 is missing somewhere. 84, we have D. 95, 94. These two are character variable, right? From 94, we have a gap. After that, they are allowed, they pick the memory. We have a memory like 93 and 92, 91, where they are. They are not using it, right? After that, C is reserving memory from 88, from there 4 byte. So D is reserving 84, right? But here, if you look at X and Y, they are in the memory location 56 and 60. as they are integer, they have 4 byte offset. That is okay. So still they are storing it in stack, but the addresses have gap in between them. Right. But when you look at this address of add function, that is completely different. It is not from stack memory, it is from program memory. So here it is 4199,791. So this is the address of that one. So it is program memory address. So when we say certain functions, the functions are nothing but a named memory location in program memory. Variables are named memory location in data memory. So the identifiers, if you look at these variable names, they are also a text, English based text. Add is also a text. They are just textual informations that we use in program, but they actually mean different things. So the variables that we use in the programs represent named memory location in data memory. Again, the functions. Functions are also in memory locations only. They are named program memory location. That is the difference. Clear? Come on.
Yes, sir.
Yes, sir.
So identify, that's what I'm variables or functions. So that is called as identifier. So I don't think that identifier means only the variable's name. No. The function names also an identifier only. Who allocated by compiler? Who allocate them? The compiler does that. While they are compiling, this process happens. Identifiers are recorded in a table called symbol table. They will maintain a table in that they will store all these symbols. Each symbol will point to some address. They will equate. Each one of these symbols is a memory address. Because the computer, microprocessor, microcontroller will only work with the memory location, not with the textual information. Right now. So each one of them has an address that is recorded in a table called symbol table. Upon compilation, identifiers are translated to machine instructions with address. So when they are going into binary code, all these symbols that we have for variables and for functions will be replaced by respective address. Got it now? In binary, when they go into the binary, we won't have these add or x, y, z, nothing. Everything will be translated to the address that we use, probably from stack or from heap or from program memory. To that one, they will translate that. Who will do that? Compiler will do that activity. Got it now? Can be any word which begins with a character or an underscore. So identifier, while defining identifier, they have certain rule. You should not start the identifier with a number. 1A, 2B, they cannot be a variable identifier. But it can be like this. B2, C1. First, you have to start with a character. If you don't like to start with a character, you can start with an underscore. But you cannot start with a symbol like ash, something like that. And you can also start with a number. The numbers that we have, no, even you cannot use them. Clear? So the identifier rules to define identifier. Again, the identifier that you choose cannot be a keyword. You cannot create a keyword, a variable called int. So you should not do like that. So while you are picking identifier, you have to pick it appropriately by following these rules. Right now.